Good morning, everyone. Am I audible to you guys? Okay. So today we will just start with the new unit, which is all like sorting algorithms and a graph. Sorting I have already started in your lab class, which is bubble sort. So I hope everyone, yeah, bubble sort we discussed in the last class. So we have different types of sorting algorithms starting from bubble sort, selection, insertion, merge, heap, and so on. Then after finishing sorting algorithm, we will see the graph. Okay, graph portion is not that much. So anyway, so I hope everyone is clear with the bubble sort. Okay, so I don't need to repeat bubble sort, I guess. Bubble sort is the simplest one where we just compare the adjacent elements one at a time. So if there are like 5 elements, how many passes will be there? At the end of bubble sort, the biggest or the largest element goes to the correct position, which is the last position. Yes, correct. If there are n number of elements in an array, the number of comparison will be n minus 1. That means there will be n minus 1 passes. Then again in each of those passes there will be some comparison, correct? Suppose in pass 1 the largest element will be in the last position. In pass 2 the second largest element will be at the second last position and so on. Again in every pass there will be some comparison. What is that comparison? We need to find out which one is the largest element and which one is the second largest element. That's why in the program also we could see two loops for bubble sort. The outer loop was for your passes and the inner loop was for the internal comparisons, means adjacent comparisons. Okay, so after bubble sort, I'll just start with selection sort. So in bubble sort, we find the largest element, right? Largest element goes to the last position. Now in case of selection sort, the smallest element comes to the first position. Okay, so what happens here? Hey, it just intro one. You guys already know sorting means you just arrange the items in ascending or descending order, but by default it's always ascending. Okay, so whenever I say sort the elements, always by default it will be in ascending order. So how it works? Your selection sort is the simplest one again, and the main thing is that this is divided into like sorted and unsorted part. Okay, most of the sorting algorithms, selection, insertion, everything, it's has a like concept of sorted and unsorted part, but in the same array. Okay, so what happens here? We just subdivide into two parts, and sorted part will be at your left side and the unsorted part will be at the right end. So initially the sorted array is empty. Okay, the sorted array will be the empty one. Then the whole entire list will be the unsorted array because we want to sort an array, right? So we just first consider the left side will be your sorted part, which will be empty initially, and the entire list will be your unsorted part. So main thing is that first we will find the smallest element of the array and place it on the first position. Then again find the second smallest element of the array and place it on the second position, and this process will go on. So again you can see there will be n minus 1 passes for n number of elements in an array. So in this type of sorting is not exactly suitable for your large data set because complexity is like O(n) square. Okay, so let's just see an example. So first, what's the thing? What I said? Just think as two parts, like this portion is your unsorted array, okay? And this part, just imagine this is your sorted array. So what we need to do first, we need to find the minimum number or the smallest number. So how will we find the minimum number? So what's the process? We'll find the minimum process. We will start with the first place, then we will find the second minimum number, then we'll place in the second position. So to do that, what we need to do is we will just set the first element as the minimum. Okay, so in this case first element is your 20, so I'll consider just 20 as the minimum. Next your passes will come. Okay, now I will compare that minimum value with the second element. Now if my second element is smaller than the minimum, then I will just assign that second element as the minimum. Then again I will compare the minimum with the third element, and if again small, we will just assign the new minimum. So this process will just continue. So in this case, first I say 20 is my minimum, correct? So if 20 is my minimum, I'll just compare with the next element, which is 12. Now 12 is smaller. So at this point our minimum is 12, correct? Because initially 20 was my minimum. Now I compared with the next element, which is 12, and 12 is smaller than 20. So I just assign 12 as my new minimum. Now second, I will just compare this 12 with the next element, which is 20. Again 10 is smaller. So in this case my minimum is 10, right? Now again I will compare 10 with the next element, which is 15. 10 is already smaller, so I will do nothing. Then I'll move to the next array, which is 2. Now 2 is smaller than 10. So at this point my minimum is 2. So now I already found the minimum value. Okay, so since I found this minimum value, I'll just swap the value with the first position. So what was the first position? 20. So I'll just swap the position of 2 with 20. Okay, I'll just swap these values. So this is the process you will find a minimum. So this is the end of pass 1. So after pass 1, your minimum value, the smallest element of the array, will place in the first position. So next is your pass 2. So this one is already set, no need to do anything, already sorted. So now in this case, this is your unsorted part and this is sorted part. Okay, so now 12 is my second element, unsorted element. This is the first. For the unsorted sub array, 12 is the first element. So 12 is my first. So I'll compare with 10. 10 is smaller, so I'll just set min is 10. Then again 10 I will compare with 15. 10 is already small, I will do nothing. Then again we go to the next element, which is 20. Again compare, 10 is the smallest. So 10 is the smallest. So what I will do, I'll just swap the value with the second largest. Here I'll just do the swapping. Okay, next again pass 3. This one is unsorted and this one is sorted now. So again first element is 12. 12 I'll compare. Here min is 12. Here also first min was your 12, but of course 12 is less than greater than 10, so new minimum is 10. Okay, now again same process we will continue. Compare with 15, 12 is smaller, compare with 20, 12 is smaller. That means what? 12 is already in the place and we don't need to do anything. Okay, so next again, that means this part is unsorted and this part is sorted. Again 15 is your min, so I'll compare with the next element. 15 is smaller than 20, so it's already in place, so I don't need to do anything. So finally after pass 4 I got the finally sorted list. So how many elements here? 5. So number of comparison or pass is also 4. It's just like the bubble sort. What happens in bubble sort? The largest element goes to the last position, and in case of selection sort, the smallest element goes to the first position. So complexity analysis also the same. There will be n minus 1 comparisons. So complexity is O(n) square and space complexity is O(n). So clear with the selection, everyone? So first step, the main concept is find the minimum and place it the first position, find the second minimum, place it the second. Okay, so everyone clear? Only do large set here, clear. Okay, so here just find the minimum, place, and first one you will just take it as the minimum, then you will compare. This is just the basic concept how we find a minimum number, right? Yeah, okay. So if this one finished, then I'll just go to the next sorting algorithm, which is insertion sort. Sorting is actually easier. Wait. Next we will come to insertion sort. Just leave this part. I'm sorting. So what happens in insertion sort? Okay, so in insertion sort also it's kind of similar. We just divide things into like sorted and unsorted part. Okay, so this insertion sort is like very basic example is like our cards. So whenever we play card games, I remember some of you told that you haven't played card games, but anyways, in card games, whenever we sort it, we just find the number and put it in the right place, right? So in this case also, we will just find the value and put it in the correct position. Okay, so in this case also, uh, we'll start with the array and we will set that the first element is already sorted. Okay, you guys are aware of card game, right? Just remember the card game, the whole concept is just the same. We just assume that first card is already sorted, right? Then we just select an unsorted card and place in the next next hand and so on. So in this case also we will select the first element as the sorted one, then we will find out to the which one is unsorted and place in the second place. So what happens here? For every pass, it inserts an element from an unsorted list to the sorted list until all the elements are sorted in array. So how it works? So first, just think that first element is already sorted. In case of selection, we just selected that left side will be the unsorted array and entire list is the entire list is unsorted and the left side is sorted position. But in this case, we will consider the first element to be the sorted one. Then I'll just pick next element. Then we'll compare with all the elements in the sorted sublist. Okay, then I'll just shift all the elements in the sorted sublist that is greater than to be sorted. Anyways, I'll just show the example, it will be clear. So suppose this is the example. So this is my list. Okay, so in this case, I just consider the first element to be sorted. What is the first element? 4. That means I'll consider this one is already sorted. Okay, so after that I'll just go to the next element. So what is my next element? So yeah, first element I'll just consider sorted here. So I'll go to the next element. What is next element? It's 6. Now I'll compare 6 with the 4. So you can say this is unsorted and this is sorted. Right? I'll compare the element from the unsorted sublist with the element from the sorted sublist. Okay, and I'll just compare with the left side of element, not the right side. Okay, now 6 I'll compare with 4, but 4 is already less than 6. That means 6 is already in place. Correct? That means once this is already in place, so this one is our sorted element now and rest is unsorted. So now our next element is 1. This is again sorted. This is un. So now element is 1. Now I will compare this element with the all elements in the sorted subarray. So 1 is less than 6. That means what? It's not in the correct position. 1 is the smallest one here. Since 1 is less than 6, so I'll just swap this value. After swapping, 1 will come here, 6 will just go this side. Now again, I'll compare this one with 4. Now again, 1 is less than 4. That means what? I'll do the swapping again. So finally, 1 will come in the first position and rest will remain here. So now this is your sorted and this one is your unsorted. Right? So now my next element is 5 for the unsorted. This is my first element. Now again same thing, we will repeat same thing. 5 is less than 6. That means what? I'll move it up. 5 is less than 6. I'll just swap the value of 5 and 6. So after that 5 will come here. Now again I'll compare with 4, but 5 is greater than 4 and it's also greater than 1, so no need to do anything, it's already in place. So after this pass, this whole thing is your sorted sublist and this one is unsorted. Now our next element is 2. Again we will do the same process. 2 is less than 6. So I'll swap the value of 2. Again you will compare 2 with 5. Again 2 is less than 5. You will swap. Again comparison less than 4. So swap. So finally 2 will come to its intended position. And now this is our sorted list. And this is our unsorted. Now our element is 3. Correct? Again same position, we will just compare with all the elements in the sorted subarray and we'll check with the left element first. So 3 is less than 6, I'll swap the value. Again 3 is less than 5, I'll swap the value. Swap the value. Now again 3 is less than 4, I'll swap the value. So 3 is in the correct position now. So this is your sorted array. So this one clear? Insertion. What's the main concept? You will just take the first element as the sorted one. Okay. Then you will go to the second element, and the second element you will compare with the left side of element, or you can say sorted subarray. So if the value is less than the compared item, then you will just push it to the left side. So you will just find an unordered element and put it into the sorted subarray. Is it clear to everyone? हाँ, थोड़ा स्टैक जैसा है. जैसे वहां पे स्वैपिंग था, there is no swapping here. Okay, there is no swapping here. Instead of swapping, we will just go from like one by one. Okay, no swapping. In case of the previous one, selection sort, we just did the value swapping. In here, there is no swapping. We will just move it like one by one. Is it clear, everyone? So in case of selection, you will just think entire array is unsorted, and in case of insertion sort, you will consider the first element as sorted. Okay, then you will just add up all the unsorted elements from the right side to the sorted subarray of the left side. So complexity is again same, like average and worst case, it's O(n) square. It's just same. Is it clear, everyone? If clear, then I'll just give you a homework. You need to, okay, you say clear. So we check 3 types of sorting. Bubble sort. In bubble sort, largest element goes to the last position. Then we saw selection sort. In selection sort, the minimum value goes to the first position. And in case of insertion sort, it's like your card game. You will just take first element as sorted, then you will just find any unsorted thing and put it into the sorted sublist. Okay, in case of bubble sort and selection sort, we could see the swapping thing. In case of bubble sort, the swapping is only between adjacent elements, adjacent values. But in case of selection sort, swapping is between the first element and the largest element when we find it. And in case of insertion sort, there is no swapping, but it will just move one place at a time. Okay, is that clear for everyone? If it's clear, then I'll just give you homework. this one we do bubble sort. We do 15, 6, 16, 6, 8, and 5, 2. Then comes your selection sort. Okay, so you need to show all the passes. Okay, no shortcut. Like it's cannot be like you are just showing the initial array and you are showing the last array. No, you cannot show that. You have to show the every pass. Okay, yeah, for everyone. Do not show just initial and the final. Show every pass how you did it. And it's for everyone. You submit in the next class. Okay, is that okay for everyone? Yeah, okay, just write it down. Yeah, next class. Yeah, sure. You can, means last date is till your last class, but of course it's good if you can submit earlier. Okay, let me just increase some numbers here. There will be more passes then. Okay, let's edit one more item here. Let's see again. Okay, everyone, have you written down the homework? If yes, I can just finish the class for today. Two sorting algorithms in one day is fine, but if I teach like more than two, then it will be confusing. These three are like the mm, means very basic and simple one. Okay, so fine, everyone. Have noted down your homework. So if yes, I'll just stop sharing and take your attendance and end the class. Okay, I take attendance. Okay, attendance noted. So I'm ending the class now. Thank you, everyone.